This is basic training, part 1, components. We left off with this problem. We would like to get this LED to work. The information that we've received about the LED is that it needs 2 volts to operate. We went to the market to find a 1.5 volt battery, or found a 1.5 volt battery. We ask ourselves the question, why don't they make 2 volt batteries? That would have been the right energy for the LED. We don't know why, but this is how it is. So how do we solve this problem? Obviously 1.5 is not enough. One option is that you can use the information that you learn in your circuits class. You could take one energy source and connect them back to back like this, so that the positive of this energy source would connect to the negative of that energy source, the negative here, and then lastly the positive over here. And now the total energy available would be 3 volts. Why? Because 1.5 volts is here, and 1.5 volts is here, and since you joined them in a way that minus goes to plus and minus goes to plus in the same direction, the energy just keeps increasing from point A to point B. As long as these are touching, then the energy just keeps going up. So now you have an energy source of 3 volts. You've seen this many times in torches, or flashlights we call them, and other appliances. You've seen batteries being arranged in this way before. Now we have plenty of energy to operate our LED. But now the problem is you have too much energy, because you have 3, but you only need 2. This could be a problem. If you give any object more energy than it can receive, what happens to that object? It becomes damaged, either by mechanical or electrical or chemical problems. Now you might remember that a resistor can reduce energy. Now the resistor is not so boring anymore. The resistor becomes a very exciting component, because now the resistor can help you solve this problem. If you somehow insert the resistor in the path of the energy source, then you might be able to reduce the energy down to the 2 volts that you need to correctly operate the LED. Let's look at this example. You learned that an energy source can be represented with this picture. You also learned that an LED can be represented with this picture. And you also learned that a resistor could be represented by this picture. Now, in order to transfer the energy from the battery to the LED, you must use wires. So I'm going to transfer that energy to the LED, but I'm going to put this resistor in the path, oops, of transfer. Why? Because over here I have 3 volts of energy, and over here I only need 2 volts of energy. So the job of this resistor is to reduce the energy from 3 volts to 2 volts as the energy follows this path, which means this resistor has to reduce the energy by 1 volt. That's its job. We're almost finished with our problem. The question now becomes, what should the value of this resistor be? Well, we have another electrical measurement called current. Current represents the energy being transferred. And we say that current flows through devices and along a path. And we have explained to you before that current flows from the positive side of an energy source through the circuit back into the negative side. And that value of current is determined by the amount of energy and the type of component that's in the path. You have some components like wire where the current will rush through because the wire offers very little resistance to the flow of current. So we call those conductors. Then you have something called plastic where the current struggles to get from one side of the path to the other. And the current is very small and it takes forever to get from one side to the other. So we call those insulators. And then you have other components that slow it down a bit, and such as, for example, a diode or silicon. And this type of material is called a semiconductor because it's somewhere between plastic and wire. Now, the range of components between conductor and insulator is basically infinite. But we have discovered that if we, somewhere along this path, there's something called resistors, which is created out of some type of carbon material. And we can design those resistors to give us the exact amount of resistance that we need to control that current through this path. The relationship between the energy and the resistance and the current is given by this mathematical formula. Now, when you buy a component, usually it gives you two values. It has to. because that is what describes the electrical properties of the component, its voltage and its current. In our example, we can use 2 milliamps of current, which will give us a good amount of light from this LED. And because this path is one single path, there's no way to escape from this path, the entire circuit must carry the same amount of current. So the 2 milliamps will be the same value wherever you measure, including the resistor. So now you can use those two numbers to calculate the resistance that you can purchase or buy to complete this problem. After doing the math, I calculate this to be equal to 1,000 ohms. So I would go to the shop, ask the shop for a 1,000 ohm resistor, and I can complete this circuit. Here, I would basically take this and join it to here, take that, join it to one side of my resistor, and then take that to complete the path, and my LED will shine brightly. Now, isn't this more exciting than just doing resistors in series and parallel? We will continue this with part 3.